Section 7.5, Day 2, we're still working with vectors and the algebraic approach for them. So today we're going to be focusing on the dot product formula and then to find a scalar value to calculate the angle between two vectors and determine if two vectors are perpendicular. So the definition of dot product is the dot product of two vectors u of ai plus b of vector j and v equals ci plus dj is written u dot v. And now this isn't a multiplication sign, this is dot for dot product of u and v. So the dot product of u and v, we are going to take the coefficients of the i's and multiply those together. And then we're going to add that to the coefficients of the j's being multiplied together. And then our answer is going to be a number value. So this is something you're going to want to memorize, the formula. And once we do it a few times, you'll probably have it down. So for example 1, we have u dot v when u equals 3, 4. And remember, this represents the I and the j coefficients. So to find our dot product of uv, that's going to be 3 times 2 plus 4 times 5, which would be 6 plus 20 equals 26. So our final answer is just a number value of 26. And we can have negative numbers, like our second example, b. Again, we have our I and our j's, and our dot product would be negative 1 times 3 plus 2 times negative 5. We would get negative 3 plus negative 10, which would give us a dot product of negative 13. And then for our next example, for the dot product between s and w, we're going to take our coefficient of i's and multiply those together of 6 times 2, and then add the product of our j coefficient, or j vectors. So 3 times negative 7. So that would be 12 plus negative 21, which will give us an answer of negative 9. So these are 3 different ways that we would be presented with vectors and how we would be expected to find the dot product. It's very similar even if they give us the vectors in where we're given the name of the vector or we don't have names, or where we are given names and they're written out in terms of I and j. So the reason that we use this dot product is so that we can apply the formula for finding an angle between two vectors. And the angle between two vectors we find by taking the cosine, which is equal to the dot product of the two vectors. And then remember on the bottom, I know it looks like the absolute value, but this is the magnitude of u and the magnitude of v. And remember, that was the square root of a squared plus b squared. Okay, so for our first example, we're going to find the angle between u and v, where u is 2, 3, and v is negative 3, 2. So what we're going to do is we're going to put cosine of theta equals the dot product of u and v. So we're going to take our i's and multiply those together. 2 times negative 3 plus our j's multiplied together, 3 times 2. And then on the bottom, we're going to find the magnitude of each vector. So remember, the magnitude of u would be 2 squared plus 3 squared, all under the square root sign. And the magnitude of v would be negative 3 squared plus 2 squared. Oops. And we're taking the square root of that. So then we can start simplifying. Cosine theta equals 2 times negative 3 is negative 6 plus 6, which is going to be 0, all over, and we're going to get the square root of 13 times the square root of 13. And on the bottom, that would just simplify to the cosine of 0 over 13, because when we take the square root of 13 times the square root of 13, the square root simplifies, so we're just left with 13. So then what we're going to do is find the angle for cosine of theta, where it equals 0. So because 0 is on our unit circle, we can use that to find our value, or we can use our calculator. So if we did the inverse cosine of 0, that would give us 90 degrees. So we know theta is going to equal 90 degrees. Now, because this is cosine, oh, sorry, my calculator gets bad. But because this is cosine, we do not have to worry about finding the second angle because cosine is already doing that for us. It's finding the angle that is relevant between the two vectors. So you just right away are going to take the answer they give you. You don't have to worry about finding a second angle like we have in law of sines. So for this one, our answer is just theta equals 90 degrees. Okay, so if you want to, use that formula and try letter B on your own. And one thing I want to mention, that this will be given to you on the quiz or the test. So you don't have to memorize this one, you just need to know how to use it. So go ahead, try B. Once you get your answer, you can press play. So when you set up this formula, you should have had cosine theta equals 6 times 1 plus negative 1 times 4 all over the cosine of, oh wait, not cosine, I'm sorry. I was thinking of the wrong thing. The square root of 6 squared plus negative 1 squared times the square root of 1 squared plus 4 squared. So for this one, you would have noticed on the top we would have got 2, and on the bottom we would get the square root of 37 times the square root of 17. So these ones aren't very nice numbers. So hopefully what you did next is you took this and you did cosine theta equals, and then you plugged it into your calculator. When you plug this into your calculator, if you're using the division key like I am on mine, you are going to want to put parentheses around your denominator if you leave them separate. And the reason is because if you don't, your calculator is going to follow PEMDAS, and it's going to end up multiplying by the square root of 17 instead of dividing by it, which is what it's supposed to do. So if we put that in our calculator, we're going to get an estimated or rounded value of 0.079745. So just some numbers, and we're going to look for theta. And remember, because we're using cosine, we don't have to worry about any ambiguous cases. So we're going to do second cosine of 0.079745. Enter. And then we get our angle of about 85.4 degrees. And that's our answer. So that would be our angle between the two vectors. All right. Next, another application for the dot product is determining whether two vectors are perpendicular. So we won't need our calculator for this part because it's pretty easy. So the angle between two vectors is 90 degrees when they're perpendicular. And since the cosine of 90 is always 0, that means the dot product of two perpendicular vectors must also be 0. So anytime you find the dot product between two vectors, if it equals 0, we have enough information to say they are perpendicular. So for this one, we're going to figure out between u, v, and w which ones are perpendicular. And I don't know why this is over here. So let's go to text. And let's move this over. Give me one moment. Just want to make this so it's not on a separate line. There we go. Now we can see them all. Okay, so we have vector u, v, and w. So I'm just going to start with vector u and v and find the dot product of that. So remember, we take the coefficients of I and multiply those. 8 times 3 plus the coefficients of j being multiplied. 6 times negative 4. And you'll notice when we multiply these, we're going to get 24 plus negative 24, which equals 0. So this tells us vector u is perpendicular to vector v, because the dot product equaled 0. Now let's try u and w. If we find the dot product of this, we're going to take 8 times 4 plus 6 times 3. 8 times 4 is 32 plus 18. We are going to get 50. So because these two, the dot product does not equal 0, we know u is not perpendicular to w. And the last two that we haven't done yet are v and w. So if we do the dot product of v and w, that would be 3 times 4 plus negative 4 times 3. We will get 12 plus negative 12, which does equal 0. So v is also perpendicular to w. So that's how you can tell if two vectors are going to be perpendicular or not, is if their dot product equals 0. So the next quiz that we're going to take is 7.3 to 7.5, and then the assignment is listed below. Don't forget to check your answers with the answer key, and then let me know if you have any questions.